All right. Well, happy Monday, and we'll take a look. Okay, so it's week 5. Homework 3 is up. There's data camp homework. There's kind of a lot of homework this week, so get started early. This week I want to introduce pandas. So we've covered NumPy, which is kind of the package that we use that handles these NumPy arrays, values of the same type. And then we have another package called Pandas, another module. And Pandas creates data frames, which is very important for us to do data science, right? And so the way Pandas is structured is that you have these two-dimensional structures where you have rows and columns. The columns are NumPy arrays, okay? Each column in a data frame in Pandas is a NumPy ND array, and so this requires all the values within a single column to be of the same data type, and that kind of makes sense. Technically, they are stored as Pandas series, but basically a Pandas series is a NumPy array with an index attached to it. All right, so the convention is to do import NumPy as NP and import Pandas as PD, and so we can do that, and that should that will load up our two important libraries here. If you installed Python via Conda, it should also have, or Anaconda, it should have installed Pandas as well, and so you should be able to do import Pandas, no problem. But if you need to, you can do a Conda install Pandas or pip install Pandas to get those modules in there. Okay, so before we get into data frames, we first have to talk about series, because a data frame is basically a bunch of series arranged together into this table. So the most basic data structure in Pandas is a series, and you can do it kind of like building a NumPy array. Okay, the key thing that differentiates a series from a NumPy array is that a series always has this attribute called the index, and so we can create a series doing pandas.series. We put in our data, and then we can specify an index. If we don't specify an index, Pandas will create an index for us. It will basically be a range index where we start off at index 0 and just enumerate 0, 1, 2, 3 for each observation. So here I'm going to go ahead and just kind of take this list with these values 0.25, 0.5, 0.75, and 1.0. We'll make a series out of that, and then I will go ahead and print the data. So you'll see what the data looks like when it's printed, and then I will also ask to print the type for the data, and it will say it's a Pandas series. So this is what it looks like when you print a series. It does the values 0.25, 0.5, 0.75, 1.0, and then you'll also see it enumerates them. This is the index 0, 1, 2, 3. So I don't think there's any surprise there. The dtype float64 is part of what gets printed out when you print data. And then here, when we say print the type of data, it prints out this class pandas.core.series.series. Okay. When you just return the data type, it comes out like this. Okay. So this looks just like printing it out. And this is the Pandas series. The Pandas series comes with a couple attributes, so you can extract out the values. Okay, so you can do data.values, and that's going to be a NumPy array. So if we say, hey, what is the type on data.values, it's going to come back and say it's a NumPy.nd array. So the values inside a series are a NumPy array, and the series or the values get paired with an index. So we can also do data.index, and it says here we have a range index. This is kind of your default index that Pandas creates, and basically it's like a range object, but it's specifically an index object. Okay, and so this will say this is a pandas.core.indexes range.range index. Okay, and so again, all series are basically NumPy arrays paired with some kind of index object. You can treat Pandas series just like you would treat any other kind of Python object. So you can subset using square brackets. So I'll do data square bracket 1, and we just get the floating point value here, right? So anytime we ask, you can always ask, what is this type here? And here it says this is a float 64, just that value. Here I'm going to slice. I'm going to slice it. Okay. When I slice from 1 to 3, right? What I get back, if you slice out multiple values, you're going to get back a series. So that's an important differentiation. All right. When you just pull out one value, it's not a series of length 1. It is just the float value or the integer value, whatever that is. Okay. But if you slice out multiple values, it returns a series. Here I can do fancy indexing in that I can subset. So I'm doing data subset square bracket, and then I'm going to provide a NumPy array. Okay, and I'm going to provide 1, 0, 1, 2, which says I want the value at index 1, index 0, index 1, index 2. This is what we call fancy indexing, and so it pulls out those values at index position 1, 0, 1, 2. So we get a series consisting of the values 0.5, 0.25, 0.5, and 0.75. Okay. Now, if you don't want to use a range index, you can specify an index yourself. Yeah, question.
Is there a reason we made a NumPy array there?
Yeah, it doesn't like if you just try to give it a list. I'm pretty sure. Oh no. I guess it does. I guess it'll take it. All right, never mind. I thought they might have done an update where it'll accept a list of index values. But okay. But yeah, I guess you can subset with a list of just your indexed the indices that you want to kind of extract out. All right, so here I can specify. So again, the default is to do a range index. It's going to start off at 0, count up. Okay, but here I'm going to specify I want the index to be ABCD. No problem. Okay, so now I have the values. Okay, the values are still the array 0.25, so on and so forth, 0.5, 0.751. The index is going to be now we get an index object with the values A, B, C, and D. The data type when you do strings in an index object is object. Okay, and that's the reason why it's not string is because object type can also allow for missing values with a nan. So nan is technically strictly a floating point value, but in Python we use nans also to represent missing values. And so, so if you're going to kind of have strings or character values, string values, with also kind of the possibility of missing, Pandas calls this thing object, right? All right, so here I have, because a NumPy array, I just have this side thought here. If I do np.nd array, and if I do A, B, okay, it doesn't like that. Let me see. All right, so here I have an array object with A, B, but I don't think I can do No, that will do. So that upcasts the nan to a string. And so this is just a string with the letters NaN. But here this will be nan, and I can combine nan with 3.0 and something like that, and that's no problem. But if I try to include an A here, that's going to upcast everything into a string. So we don't want that. Okay. So that's data type, basically characters or strings. Pandas allows for kind of the mixing of string as strings and then nan as a missing, not the letters NaN, but an actual nan as a missing thing. Okay, so that's what we have here. Okay, data square bracket 1 will kind of just pull out the value 0.5. So keep in mind, this is a series. All right, so this is a little bit different from a dictionary, right? A dictionary, you have keys, and if you say, hey, give me, if your keys are A, B, C, D, and you say, give me index position 1, a dictionary says no. There's no index position 1 with a dictionary. But with a series, okay, I can get index position 1, and that will be 0.5, right? I can say I want index position A, and that's fine. I can say I can slice from index position 0 through 2, and that will give me 0.25.5, basically corresponding to indices A and B, right? And you can also slice by name. This is this is different from slicing by index position. If you say slice from A through C, it will return C. Okay, so it will start at index value A, and it will return A, B, and C. So it will slice from there to there. So which is different, right? Because you might think slicing from 0:2 and slicing from A to C are the same, but their behaviors are different, right? You're slicing by index position, and this kind of works the classic way. But if you slice by name of the indices, it returns that thing. Yeah, question.
Could series be like multi-dimensional? 3x2?
So a series is unidimensional, but you can have a multi-level index. So I don't know if that answers your question or not. So you can have we can have a multi-level index, but the series itself will always be one-dimensional. Okay. Yeah. Question.
Are you able to do the same thing as like a series with the enumerate function?
So that's kind of the default behavior when you just create a series and you don't specify the index. It enumerates basically starting at 0, or is that not your question?
So it's basically the same thing as enumerate.
Well, here, let me. So enumerate basically will creates an iterator where it's going to pair basically a 0, a 1, a 2 with the thing. So if I create A, B, C, so I have this list, and then if I say enumerate, so I get a enumerate object, and so if I throw that into a dictionary, I will get this. Let me see. If I throw this into a list, I think I get a bunch of tuples. Okay. So let me see. Can I do pd.series on this? No. Wait. How do I do? Oh, pd capital S. See, these things, they still get you. Okay. Yeah, it does it like this. So it treats it like so it creates an index 0, 1, 2 along with the tuple 0, A, 1, B, and 2, C, which is probably not what you had in mind. Or is this what you were asking?
I was just trying to understand kind of the difference between enumerate and just PD series.
So PD series is kind of like enumerate, but it makes a series out of it. Okay, whereas enumerate, like, it creates. So enumerate zips, and it creates what's called an iterator. So the enumerate is lazy in that, like, it doesn't know that 1 gets paired with a B and 2 gets paired with a C until you ask, I want you to, like, tell me what these things are. So it's just kind of like instructions where it says, okay, and Python treats it like, all right, I'll get to it when I get to it. All right, okay, you want to know what the first one? All right, that's a 0 and it goes with the A. You want to know what the next one is? 1 and gets with a B. I don't even know what's next until you ask me. And then when you ask me, I'll say, all right, it's 2 gets paired with a C. But you could say, I want it all now by throwing it into list or throwing it into dictionary. But yeah, let me see. If I make a dictionary out of this, I get this. And let me see if I can do pd.series. Okay, so if you take a dictionary that was built out in an enumerate object, it will do this. Okay, so maybe this is, I don't know. So I guess so yeah, if you have a dictionary, it will take the keys and use them as the index. But okay. So we have that. All right. Here is a dictionary. Oh yeah. Okay. Well, here we go. We've taken the dictionary and we'll make a series out of the dictionary. So here I've created a dictionary with, like, the OG original Avengers. Okay. I don't. Do we still like the Avengers and Marvel stuff? Maybe. All right. This is what first Avengers came out in 2012. I don't know. Now it's over 10 years. I don't know. Battle of New York. All right, whatever. Okay. So we have Tony Stark, Steve Rogers. All right, so their character, I don't know, not their superhero names, but their, like, person names. And then the actors that played them. Okay? And then we can say, all right, what's the index on this thing? So here's our series, and I can ask what's the index. The index is basically these values. That's object type. The values themselves is this array, also object type. Okay. I think these are kind of made up numbers. I think this is how old the characters are in universe when Avengers 2012 took place. So I think Steve Rogers is 104, right? Because he was, I don't know, whatever. And I guess Thor is 1,500 years old, 1,493. I don't know where they come up with these things, but I guess that's that. All right, and so we can create this dictionary, and we have this, okay. And then, and we can also create another dictionary where we have their superhero names, right? And so, Steve Rogers is called Captain America, and Natasha Romanoff is known as Black Widow, and so on and so forth. Okay, so we have this, and then what we're going to do is we're going to take these individual series. So we took the dictionaries to make series out of them. And then we're going to make a data frame, all right? So here I'm going to take multiple series, and we're going to kind of join them together into a data frame. And so here I'm creating the data frame built out of a dictionary. This is a dictionary where we have the key as the column name as the key, and then the corresponding value is the actual series itself, all right? And one thing I want you to notice is that these series, so this one, the order, we have Tony Stark, Steve Rogers, Natasha Romanoff. is in a different order from this: Thor, Steve Rogers, Natasha Romanoff, and so on and so forth, okay? But when I say, hey, make a data frame out of this, so pd.dataframe, and I print this out, it pairs them up, and then kind of the default is that after it aligns the series together based on their index, it prints it out in alphabetical order. So it sorts based on the index. So it says Bruce Banner, played by Mark Ruffalo, hero named Hulk. I guess it was age 42. I guess that's the perfect age to be an Avenger, huh? Okay. Oh, and they had like there was like a romance thing, right? Between Black Widow and Bruce Banner. Was that not a thing in like Age of Ultron? Sort of? No? Okay. I'm the only one who watches these movies. All right. I didn't realize there was a 14-year-old difference. Okay. I mean, I guess that's fine. That's what is this? 42 divided by 2 plus 7. I guess it's right in there. Okay. Okay, so we say, hey, what is this data type? That's says it's a data frame. Okay. All right, that's okay. So that's a data frame. So this is the index. The index is over here, and then we have the columns: actor, hero name, and age. Okay. So the index itself is technically not a column. It's an index. Okay. Here, what are we going to produce here? I have a list of dictionaries: A, B, A0, B0, A1, B2, A2, B5. So this is a list of dictionaries. And here I'm going to create a data frame. I'm going to provide the index 1, 2, 3. All right. So we're going to make a data frame out of this list of dictionaries. And so what this is going to create is it's going to create a data frame, index 1, 2, 3. And we're going to have a column A and a column B. And that's what our data frame looks like. Okay. Here I have create another dictionary. I've got A0, B0, A1, B2, A2, and C5, right? And so when I say make a data frame out of this, okay, I say make a data frame out of this, then it's going to recognize that as far as the keys in these dictionaries go, we have A, B, and C. And it says, okay, A is this, all right? B, we have nothing for the third observation, so it creates a nan. And then C, we don't have anything for the first two, so it creates nans there, all right? We didn't provide an index, so it specifies 0, 1, 2, okay? And then what do you notice about the data type in column B and column C? They got upcast to floats, right? And so now they have 0.0 to indicate that they are floats, because nans are always going to be a float. And so so that's what we have here, okay? The other thing is that this is a thing about Jupyter Notebooks, is that when you print a data frame, and if you call print specifically on the data frame, right? So when you call print, notice there's no out, right? So we have square bracket 45 as far as the input command, but no square bracket 45 as far as the output, okay? Because it's not returning an object. The returned value is a none. It's just outputting stuff to the screen. It gets printed to the screen. Whereas here, we are actually asking for the object itself. So input 47 outputs an actual object here. And when you just output the actual data frame, Jupyter kind of does a little bit of like formatting, and on my computer, when I hover over it, it like changes the colors and stuff like that. So this is just how Jupyter formats actual data frames when it gets output. Oh, let me give you your first view quiz answer.
Professor?
Yeah.
So the series only has index and one
column, but the data frame combines series.
Yes, data frame is multiple columns, and each column is a series. Okay, so yes, a series is basically just one column. Series is just one column, and a data frame is basically a table with multiple columns. So question 1 is A for your lecture view quiz. The other thing you can do is you can create a dictionary to a data frame, and so here I had a list of dictionaries, right? And each dictionary here was one observation. Here I can have a dictionary where each entry, each key and value, the values can be just basically a column. See here I've got A is 1, 2, 3, and B is X, Y, Z. All right, so here I have a dictionary with that, and I can make a data frame out of that as well. This is all like manual creation of data frames. We probably never will create. I don't want to say never, but you're not going to be creating data frames manually. All right. Generally, you'll just do like read in a CSV file. So that's probably your most common way of getting your data. But sometimes you just like need to like add a column or something, and you might want to like create something or create a series of values or something. And so I think it's still handy to know like how do I make my own series, or like how do I kind of pair a couple things together into a data frame. But this is all like manual creation of a data frame, which is not something we normally do. But these are the ways you can do it. Okay, so here I've got a dictionary, key A, list 1, 2, 3, key B, list X, Y, Z, and we make a data frame out of that. Now, if I do it with arrays that are different length, okay, now Pandas gets angry with me, right? And this is the unfortunate thing. So a lot of times errors in Python are easy to read, except when you're using like NumPy or Pandas and you encounter errors, then you get like all of the kind of the internal code, because you're like, I didn't call this, but this is like the code. When you say make a data frame in Pandas, it like runs a whole bunch of functions, and then like it gets angry here. And so here I have A is the list 1, 2, 3, 4, and B is the list with X, Y, Z. These arrays aren't of the same length, and so it gets really angry. And actually, this error message is helpful. All arrays must be of the same length, and then but sometimes a lot of the output can be not as helpful. Okay, but in this case, it knew what you did wrong, and it says the arrays must be of the same length. Okay. Here, I just want some random integers, and I want to, and I turn them into a matrix. Okay, 5 by 2 matrix, and then we can say, hey, you know what? I want to make a data frame out of this. All right. So we could take this 5 by 2 matrix, and I could say, make a data frame where the column names are going to be X and Y, and then my index values are going to be A, B, C, D, E. And again, if you don't specify the index values, it's going to default to a range index starting at 0. But you can take a matrix and make a data frame out of it. Okay, yeah, question?
Can we create a data frame also with a tuple?
With a tuple? Like a dictionary of tuples, or, I mean, a list of tuples? Like one tuple? Sorry.
Like not directly from the tuple. You have to convert it first, right?
Well, I guess the answer is yes, but depends. So like, what does your tuple, or do you have a list of tuples, or a tuple of tuples, or a dictionary with tuples in it, or is it just like one tuple? Multiple tuples, then yeah, I think so. You can kind of basically anywhere where you see a list here, I could just replace it with a tuple and it will work. So like if I have here I have a dictionary, and instead of a list, I put in a tuple here. This will work. Okay. So basically anywhere where you see a list, you could kind of replace the square brackets with parentheses, and that will be a tuple instead. Okay, but yeah, there's data frames and series. There's all kind of there's like an internal structure, right? So if you have like just one tuple, that's a one-dimensional thing. So you can make a series out of that. Okay, if you have multiple tuples, then and they're the same length, you can kind of turn them into columns by kind of putting them into a dictionary and making a data frame out of that. So it depends on everything. I guess the answer is depends, but yeah, if you have tuples of different length, then that's it. You can effectively think of a tuple as a list. So if you can do it with a list, you can also do it as a tuple. It's just lists are mutable. You can append and replace values in a list, whereas a tuple, they're immutable. Can't do that. Okay, so all right, let me go ahead and give you your second answer. All right, question 2 is E. All right, let's. So we have a data frame, and this is our Avengers. Okay, and we can say, hey, what are our column names? The column names are actor, hero name, and age. Okay, and the index are the character names. Okay, and so if you want to just extract out a column, all right, we can use dot notation. So in R, we have something similar. You use the $ notation to kind of pull out a column. In pandas, you just do with the dot. And so here that will extract out the series. All right, so column is basically a series. So the series always comes with the index, right? So you get the column values, okay? And we always get the index there. If there's a space in the column name, so generally recommended not to put spaces in your column names. We should, we don't like spaces, okay? Because spaces always you have to escape them with backslashes or things like that. So your file names, I always use underscores, and similarly for things, I like to use underscores here. But just to illustrate, I put a space in the column name, and you can get it, but you got to use square bracket, and then you put it in quotes, and you can do hero space name, and that works. But you can't do the dot notation when you have a space in there. Here we can ask, what is the type? The type is a series, okay? And then again, once you have the series, you can extract out using index position. So we can say, what was the actor in index position 1? And it says Jeremy Renner, okay? We can subset based on a condition. So we could say, give me the actors who in the movie, their character's age was 42, okay? And there were 2 characters. Tony Stark and Bruce Banner were age 42 during Battle of New York, I guess. Okay, here we can extract out based on the index. So remember, we can say, give me the hero name where the index value was Steve Rogers. So we can do that. And then here I can also slice using index values. And I can slice from Steve Rogers through Tony Stark here. Okay, and we get this. All right, and we can see Thor, we have Nan. And that's okay. We can have Nan, and it's going to keep it as object type, which allows us for the mixing of character values and missing values. Okay, we have the .loc and the .iloc, all right? So the .loc attribute is like the location attribute, and this is location based on the index value. So here I can say, give me, from our data frame Avengers, give me index location where the index is Thor, and we get back basically this row for Thor, and what we actually get back is a structured series, which is technically a NumPy array, but we're going to get back the values Chris Hemsworth, Nan, and 1493. Okay, with .loc. All All right, so we get actor, this, hero name, age, that. Okay. The type on this is it's a series, and if you ask for what are the values, it's an ND array. All right, and this is a structured NumPy array. So one thing I said is that in a NumPy array, all the values have to be of the same data type. There is an exception to it, and that's called the structured NumPy array, where you say we're going to create a structured NumPy array where the first value will always be this data type, the second value will always be this data type, the third value will always be this data type. And you can create a NumPy array kind of with that information. It carries more overhead in memory, but it is possible to do that. Okay, here I can say, give me the location. Just the colon here will do all the rows, okay? Comma, the age column, okay? So here we're gonna say, give me all the rows. So dot location, so it goes rows first, then column. So we can say, give me that, and we get the column of ages, okay? The type on the column of ages is a series, and then you can ask for the values, and that's gonna be an ND array. And then kind of like you can give it a pair of coordinates, you can say, I want basically the row corresponding to index Steve Rogers, and I want the column corresponding to age, and this will pull out one particular value, and this is just an integer here. This is just the integer. .iloc uses the index position, zero-based index position. So you can say .iloc 3 comma, so that will give you the row corresponding to index position 3. So 0, 1, 2, 3. So that will give me the row for Steve Rogers. Okay, and then we can also get a pair of coordinates using .iloc as well. So here, row 0, column index 1, which is the hero name for Bruce Banner, is Hulk. Okay. We can use assignment in coordination with the .loc and .iloc to kind of change values. All right, so here I can say I want to change Thor's age to 1500, and I want to change, right now we have Thor's hero name to be Nan, but that's going to be his real name and his hero name, okay? And we can do that, and then so I've updated, I've set the values, and then so I ask what is in Avengers the data frame, and we can see we've replaced hero name from Nan to Thor, and we've updated the age from 1493 to 1500 or something like that. Okay, so we have we can do that. So data frame, the series and data frames are mutable, no problem. You can also assign multiple values all at once. So if I want to go back and I want to replace Thor back to Nan, and then I want to replace age back to 1493, I can do that at once. I can do avengers.location, and I could say for index Thor and columns hero name and age, throw back in the Nan and 1493. Okay, and again, to get the floating point value for Nan, or the what represents a Nan, we can call numpy.nan, and that will be the Nan value, and then so we can do that, and we have Nan and 1493. So you can assign in coordination with loc or .iloc, and so here I did .loc, but again, you could have done it with iloc as well. So iloc is always index position, using starting at 0, 1, 2, and so on and so forth. All right, here is this is where .loc and .iloc, it's important to keep these straight. Okay, so here I have a data frame where the index is 1, 2, 3. The first row starts with index 1, okay, and the columns are A, B. So when I say, hey, give me data frame.loc1, okay, that's going to give me the row corresponding to 1 here. All right, so we're going to get back the values 11 and 12. All right? When I do df.iloc, okay, iloc uses zero-based index position, okay? And so we're going to get back index position 1, which corresponds to row 2, right? So just kind of want to pause here and just make sure we understand the difference between .loc and .iloc when we have a numeric index. All right, this can often lead us, if you have something like this can be confusing, right? Because .loc always uses whatever the index here is, all right? And so here we got 1, 2, 3, and so index 1 is this first row, okay? The iloc always uses a zero-based index position. So it doesn't even care, it doesn't care what's here. This first row is always going to be index 0. This is the next one's always going to be index 1, and so on and so forth. Okay. It's less ambiguous when you have an index where it's like names and stuff, but here it can feel a little bit confusing. But just know iloc always uses a zero-based position-based index here. Okay, and then if you try to say something like iloc 3, right, which is zero-based index location 3, which doesn't exist in our thing, we're going to get an error. Right? You try this, it tries it out and says, you can't do it. Okay, single position indexer is out of bounds. So here we're just saying, hey, we're looking for this thing and it's out of bounds, meaning it's not in the thing. Okay, we can do Boolean subsetting. So basically using some kind of condition, trues and falses and things like that. So we can say, hey, give me Avengers where, all right, and I want the rows that correspond to age less than 50 or age greater than 40, all right, and I want the hero name and their age, and we get these 3 characters, okay. You can also do something like, there's different kinds of stuff. So the index is the names of the characters, and we can access string-based functions. So we can say index, I want the string-based functions, and we want starts with B, and that's going to return trues and falses, and so we'll get the characters whose names start with B. Okay. Here we can say take the index, okay, treat it as a string, and then find character capital R, okay. And remember, the way .find works is if it can't find it, it returns a -1, okay? So we're going to get characters that contain capital R, because people who don't have capital R in their name will get back, we'll get back a -1. So characters who have a capital R in their name will be these 2, Natasha Romanoff and Steve Rogers. Okay, we have, you can transpose a data frame, and so this is what we get. We get, now the characters are the columns, and the rows are the different things, all right? When you can ask the data types, right? So in the non-transposed things, it will tell you like what is the data type of each column, right? And what is the shape, number of rows, number of columns, okay? And again, index does not count as a column, as part of the shape. All right, let me give you your last view quiz answer. Question 3 is A. Okay, probably the most common way of getting data into pandas is just like reading in a CSV file. That's probably one of your most common ways. So there is a Titanic CSV file, and so you can specify a file on your computer, right? And so you just kind of like a local address or something like that. It also is able to, you can give it a web address. So here I've got a URL for this CSV file, which exists on the internet, and you can just say, hey, pandas.read_CSV, and you give it the address of the file. So whether it's a local file or something on the internet, and it will do it. Okay, and so now I can say, hey, what does my data frame look like? And if it's a big data frame, it will kind of give you a ... giving you the head and the tail of the data frame, the first 5 rows and the last 5 rows. That's kind of its default behavior. If you have a whole bunch of columns, you'll also see a ... and it will give you kind of like the first 5 columns and the last 5 columns generally. I think that's what it does. Okay, maybe the numbers are a little bit different, but here it's able to fit in all of the columns, so we're okay. All right, dot shape, number of rows, number of columns, and again, index does not count, and so it's kind of funny. In the CSV file, there's a column called passenger ID, which is basically an index, but it starts at 1, right? So we have that, and then we can ask what are the column names. So we can just do Titanic.columns, and we get the names of the columns in here. The default behavior when you do read underscore CSV, the default behavior is that it's going to try to infer whether there's a header or not. But you can specify whether there's a header row or not, but it's going to try to figure it out. And it tries to do that by basically looking at the data types of all of the following values, and if the first row contains a different data type, it's going to figure out that there's a header row. Okay, the index is basically just a range index, which is the default behavior if you don't specify anything for the index. There is .info, which gives you a little bit more information about each of the columns, and so it will say, all right, this is column 0, column 1, column 2, index positions 0 through 10. The name of the column, it will tell you how many values are not missing. Okay, and so we have a total of 891 entries. Some have missing values, and so we can see things like cabin. We only have 204 non-missing values. Everything else is missing there. Okay, and then the data type, we can see we have integers, floats, and then we have strings. Strings show up as object type. Okay, and then there's one more handy function, .describe, and that will take all of the numeric data types and give you things like what's the mean and what's the median and stuff like that. So for the numeric value types, it'll tell you stuff like the count, what's the mean value, what is the standard deviation, the different percentiles and stuff like that. Okay, that's it for today. We'll wrap it up here. We'll see more Panda stuff. There's quite a bit. That's going to be kind of our big workhorse when doing working with data. So we'll see a lot more of this, and we'll see you guys on Wednesday. Have a safe and happy Halloween, and we'll see you.